Let me do this integral by 4 methods. Now here, doing integral is not that important, but rather the methods. The methods matter. Okay, we are learning the methods. Now method 1, which is the most commonly used method by parts. So this one is equal to integral e to the 2x d cosine 3x. Okay, to maintain equal sign, I must multiply by 1/3 negative. So that will equal to original integral. Then this one equal to negative 1/3. Then I can use by parts, right? UV. UV, this is U, this is V. U, V, minus V du, minus integral V du. V is this, du is a 2 e2x dx, right? Yeah. Then organize again nicely. This is 3x plus 1/3, 2/3 rather. There's 2 here. Integral e to the 2x cosine 3x. I can write the derivative over sine 3x, right? So I multiply by 1/3 again. Yeah. Then this one equal to negative 1/3 e to the 2x cosine 3x plus 9 2/9. And this is by parts again. E to the u times v minus d du. Integral this one times this one derivative, right? So it becomes 2 e to the 2x sine 3x dx. Yeah. I hope everything follows. This is negative e to the 2x 3 cosine 3x plus 9 2 e to the 2x sine 3x minus this 2 times this is 4, right? This is a 9. This is my original given integral. So this is I. This is I, right? Yeah. Then I move this one is a 13 over 9i is equal to this is a common factor. I write the positive first. 9 2 sine 3x minus 1/3 cosine 3x plus cn. Then I is equal to found is 13, right? E to the 2x times 9 becomes 2 sine 3x minus 3 cosine 3x. Okay, that is the result of the integral. This first method is quite often we are used in by parts, right? Now method 2, the integral is e to the 2x sine 3x dx. The second method, I'm using complex number. Okay, that is e to the 2x e to the 3ix. That is the cosine 3x plus I sine 3x. Now I just want a sine. Therefore I choose the imaginary part of this integral. That will be given integral. Then this is equal to imaginary part integral e to the 2 plus 3I x dx. So this integral is rather easy. Imaginary part 2 plus 3I, right? And the e to the 2 plus 3I x plus c. And this one is equal to imaginary part. I multiply the conjugate, right? So 2 plus 3I times 2 minus 3I. And on top would be e to the 2x times e to the 3ix times 2 minus 3I. And then just a straightforward calculation, this will be 13. 4 square plus 9 square is 13. Now this one, this is the e to 2x, e to 3ix is cosine 3x plus I sine 3x times 2 minus 3I plus c. And this one can be taken out. Now I want the imaginary part, and this time this one is imaginary. This one time this one is imaginary. Other would be the real part. We don't need it. So this one time this one I want. This is sine 3x. This one time this one I want is minus 3 cosine 3x. See, that is the result by using second method. Now, third method, e to the 2x sine 3x dx. I'm using differential equation. Well, we know that we're looking for antiderivative. Our integrand has an exponential, therefore our antiderivative must contain the same exponential function, which is e to the 2x multiplied by another function which is called f of x. Well, I hope you accept it. And then we differentiate both sides. This differentiate is a 2 e to the 2x times f of x plus e to the 2x times the derivative of f of x with respect to x, right? We are using product rule, which is equal to integrand. Function is 2x sine 3x. Good. Then we cancel that exponential, we get 2f of x plus f derivative of x is equal to sine 3x. So we get a first order differential equation. We cannot solve this differential equations by using the non-regular way, because if you do this, then you are the integrating factor, right? Then you go back to the original integral. So we have to use other method, other ways. Now, since the derivative and the function, the summation is sine 3x, therefore my f of x must be sine 3x and cosine x 3x, just combination. This is a times this one plus a number times this one. So the summation of these two function will be my f of x. We're just looking for AB. And f derivative, f prime of x will be equal to 3a, right? Cosine 3x minus 3b, and sine, right? 3x. Then we can find f of x by using this equation, right? We call this equation is star. Now we suppose let x be 0, then the star, this equation will be 2 times b, right? 2 times b plus 3a is equal to 0. Yeah, this is equation 1. Okay. Now let x be equal to we pick up an easy number to calculate. How about pi over 6? Then this star equation will become 2 times f of x. Well, this pi over 6, this is 1. So 2 times a. This will be 0 plus f prime of x. This is 0. This is minus 3b is equal to 1, right? Is equation 2. Then equation 1 and equation 2, we can solve them. You see, a equal to, well, I'll just save time, right? A is equal to 2, b equal to 3, negative 3. Let's check it. 6, that's correct. 2 times 4. Wait a minute. Well, I made a mistake. A is 2 over 13, and B is 3 minus 3 over. Okay, I just saved time to solve these simultaneous equations. I think you can easily to get this answer by solving these simultaneous equations, right? Then we plug back, we find the integral e to the 2x sine 3x dx is equal to e to the 2x over 13 and 2 sine 3x minus 3 cosine 3x plus c. Okay, this is a nice method, but it's not that, not very often used. Okay, let me check this answer. This plus this one 0, that's correct. This one 4, this is 9. Yeah, equal to, that's correct. All right, this is the second method. Now the third method. Fourth method. I had too many methods, it's confused. Okay, this is the fourth method. Sine 3x dx. I still use the complex numbers. This one is equal to integral e to the 2x. Sine 3x is equal to 2i here, e to the 3i x minus negative 3ix. Okay, that is sine 3x. Yeah. Okay, good. Then this one is equal to 2i is taken out, and this would become e to the 2x plus 3i x minus e to the 2x minus 3i x dx. Okay, then this is 2i this integral is there's no x. There's no x there. Well, I'm sorry. There's 2 times 2 plus 3ix. Yes, it come. Then this is 2 plus 3i e to the 2 plus 3i x. That is this integral minus 2 minus 3i e to the 2 minus 3i x plus c. Yeah, that's correct. This has to be very careful. This is 2i. Now this will 2 plus 3i e to the 2x times e to the 3ix minus 2 minus 3i e to the 2x and e to the negative 3ix plus c. I can take e to the 2x out, and this will be 4 plus 9, right? And this will be 3 e to the 3ix multiplied by 2 minus 3i minus e to the negative 3ix times 2 plus 3i. plus c. Yeah. Then I take 13 out. This is 2i 13 e to the 2x now this will be 2 this is 2, right? This is e to 3ix minus e to the negative 3ix minus this time this time this become wait a minute, this is 2, this is 2, right? This is 3, this is 3. So I have a common factor 3, minus 3. This time this one is e to the 3ix plus e to the negative 3ix. Yeah, plus c. Well, I'm confused with myself. Okay, this one times this one plus this one times this one is this. This one is this. I take a negative 3 out. Yeah. 3i, yeah? Negative 3i. I take negative 3i out. I hope you see that one. Therefore, this is e to the 2x 13 here. I move 2i inside. This becomes 2i. This is 2, right? E to the 3ix minus 3 negative 3ix minus 3i, the 3i over 2i e to the 3ix plus e to the negative 3ix plus c. Then this is a 13 e to the 2x. Well, this is sine 3x. 2 sine 3x minus. Now I cancel I. This would be cosine. Therefore, minus 3 cosine 3x plus. So that is a result. Yeah, it's a little confusing, but it's correct. Okay. See, the main confusion coming here. This time this one, this time this one, this one time this one, this time this one. Then I reorganize. This one is times 2, this one times 3 i's. Then get the result. Okay. So altogether, the 4 methods. The methods is what we are learning. Okay. So thank you for your watching.